Okay, so this next section is about histograms. Histograms is a visual display of the frequency tables that we looked at in the first section. And this is the frequency table that we spent all of our time on in that first section. You see the daily commute times and the frequency. This is not a normal distribution. But what you see here is a histogram that displays the height of each class's frequency. So 0 to 14 minutes, if you want to remind yourself, this was taking into account different people who commuted in LA and how long their commute was. And so the 6 represents that there are 6 people in this sample whose commute was anywhere from 0 to 14. So if you recall, I was referencing a number line, and so this down here is going from 0 to 105, and 105 is the end of the highest value here in the left column. So when you create a histogram, these are often referred to as bins, and the bin width is 15. As you can see, the markings 0 to 15, 15 to 30, 30 to 45. And so what you see along the side is always frequency, and whatever's along the bottom is representative of these numbers in the first column. And so the section is about being able to read a histogram, but also being able to describe the shape. So if you have a normal distribution, when you look at the numbers that are going along the horizontal, they don't have to start at 0. It depends on what the data is. If you have something that's normal or somewhat normal, you've got most of the values, highest frequency occur right here in the center, and then they taper down on either side symmetrically. If you look at this visual, you do see a high point, but that high point isn't centered. It's not where the middle of the data is, right? So if I look at, appears some of the data is like at 5 and some of the data is around 50. And if you found the middle value of those two, it wouldn't be 20. So the highest point here isn't where the middle number is when you look at all the data. So this is referred to as having a tail on the right side, and this is referred to as having a tail on the left side. Not all displays are going to look like this, but these are the more common shapes that you want to be able to identify. So the normal bell curve is so important to us, and then having skewed data, knowing whether it's skewed right or it's skewed left. And what kind of data would do this would be that I do have a lot of data points that are going from, maybe even 40 to 70, but there's a lot of spread here. There's a lot of variability, and there's not so much here. Enough that it needs to be included. So there are sometimes values that lie so far away from the pack that this is not a tail. There's a gap here. And so you could have 1 or 2 data points that are referred to as outliers. And at this level and for this entire class, you never need to tell me the technical calculation for deciding whether something is an outlier. I will go over it in another section in chapter 3. At this point right now, you just refer to an outlier as a value that's really far away from the rest of the pack, is the way I refer to it. So, what do you think? Ask yourself, I'm not going to put a question here embedded, but do you believe that this distribution is normal, left skewed, right skewed, or uniform, and how can you tell? So this is a left skew. You look at the highest point and it looks like this kind of drags down. I think sometimes of wedding gowns that have that train or whatever. This right here would be a left skew. The textbooks offers a really cute picture in your mind for left and right skewed. Your right foot is right skewed. That's your right foot, right? And then your left foot, like the big toe is the highest point, and then it kind of like tapers down. So just more visuals. I've also included here another way to describe a distribution, and that's uniform. And what you can tell here is it does not appear to be any high points. And we'll look at other things when we deal with probability later that are uniform. So just like you had a relative frequency table and a frequency table, you will need to create for me both a frequency distribution as a histogram and a relative frequency distribution. Again, taking that same example from the last section, this 12% is 12% of the entire sample. And so in order for you to get that value, you would need to know how many total people were included in the sample. And if you remember, this is 50 when you add up all the frequencies, and then 6 divided by 50 would give you 12%. So now what does that look like on a histogram? So a relative frequency histogram will have the same exact shape as the frequency histogram. It will have the same values going along the bottom, but what's different is what you see over here are not counts. It's not how many, it's what proportion of the group. And so these values will never be higher than 1.0. There'll always be decimals. And so that's the only difference between a frequency histogram and a relative frequency histogram. Another moment here for you to test yourself. Again, I'm not embedding a question here. This is just for you to kind of pause and see if you can answer this. What percent of the population are between 67.95 and 71.95 inches tall? So the heights are along the horizontal, and first I find this value that's included in the problem, right? But then if I look at the other number, 71.95, that would be going across two bins or two classes. So to answer that, I would need to add these two values up. So that would be 0.29, 29% of the population are between those heights. So this is a relatively short lesson. A lot of it is you just digging in and doing the assignment in Pearson in my lab. And what you have here is something that's included. We won't be doing scatter plots till the end of the semester, but it is involved in the lesson, and so I wanted to, you're welcome, throw it right in. And what you have here is called a quantile plot. And this is a plot that StatCrunch will create for you. And what it does is it takes residuals, which we will learn about much later in the course, but we definitely will. And each one of these dots represents one value of the set, and each normal quantile plot has this line, and what this line is telling you is how far away the data point is from the best linear model for the data. Basically, what I want you to look at is how these black dots are arranged in comparison to that line. And that out of these three different visuals, again, they can't possibly show you every kind of quantile plot that might result. But what they're showing you are three different things that might happen when you look at your normal quantile plot. So if you have a normal distribution, that's what doing this quantile plot is helping you answer, is do you have a normal distribution? If your data is normally distributed and you look at the quantile plot, then the points are reasonably close to a straight line pattern, not exactly a straight line pattern, but there's no other pattern like this one here. So if you look at this one here, it kind of looks like it's a straight line, but if you were to literally connect the dots, it's got more of a curvature to it. It goes completely above and below. And basically what that means is there is some kind of pattern, but it's just not a normal distribution. And so when you look at your quantile plots, this is definitely very tricky. It's not black and white, right or wrong. It's just something that I want you to consider. It's in the section, and it is something that you do when looking at the histogram isn't enough for you to decide whether or not you have symmetric data or if you have a normal distribution. This is another example of not normal. The points don't lie reasonably close, and what you see is all of these values have residual, is what it's called, of 0. I've got a couple of more videos that talk about normal quantile plot. I don't want you to feel like this is something you have to understand in depth. It's just a visual I want you to consider and look at, and it is related to histograms, and it's a way for you to tell whether your data is normally distributed. That is lesson 2.2. Again, remember that I have a couple other videos talking specifically about normal quantile plots and how they're related to describing the shape of your data. You also will have a lab that is related to histograms. Hopefully you enjoyed this lesson, and let me know if you have any questions.